Many individuals have harbored dreams of residing on the planet Mars. In light of the gradual degradation of natural resources and ecosystems on Earth, this dream seems increasingly viable. Our era is witnessing exciting developments in cosmic exploration, from Mars rovers to the Webb telescope. And now, the Artemis mission is poised to propel us farther into space than ever before. NASA's Artemis 1 mission marks the beginning of Mars exploration. Nevertheless, the pivotal question remains: does humanity possess the necessary capabilities to survive on Mars? Indications suggest that the answer is affirmative. Scientists point out the many similarities between Mars and Earth, though they are not identical. If mankind is determined to transcend the boundaries of the seemingly impossible and establish a thriving settlement on Mars, several possibilities are worth exploring. These include underground habitats, 3D printed structures on the planet's surface, and inflatable habitats. Today, we delve into the concept of inflatable habitats, shedding light on both the possibilities and challenges associated with this innovative approach to Mars colonization. So what exactly are inflatable structures, and why are they garnering attention in the realm of space habitat design? NASA has taken a significant step forward in proving the technological feasibility of employing inflatable habitats for human space habitation. These inflatable structures offer a unique combination of durability and an exceptional volume-weight ratio, making them a natural choice for space construction projects. Whether it's a home in space or in low-atmosphere celestial bodies, the need for pressure vessels is paramount, ensuring an interior pressure of at least 100 kilopascal. Inflatables, with their elastic exteriors, surpass conventional metallic shells by enabling the creation of larger volumes within the confines of spacecraft cargo bays. Interestingly, early plans of orbiting observatories were rooted in the use of inflatables, but NASA only recently began active exploration of this concept. Despite the potential benefits of inflatable habitats, there are noteworthy alternatives worth considering. One of these alternatives is 3D printing on Mars, a concept that has been in the pipeline for years. Recent years have witnessed the emergence of various 3D printing concepts. The core idea behind 3D printing in space involves deploying an entirely autonomous system on an extraterrestrial body and dispatching rovers to collect loose dust and rock fragments. These materials are then processed in a high-temperature furnace to create a type of concrete, which is subsequently used by a 3D printing machine to construct the habitat layer by layer. However, the 3D printing approach has its own set of challenges. To implement it effectively, numerous robots must be landed on Mars, necessitating substantial electrical power for the collection, melting, and 3D printing processes. Furthermore, the resulting structures would essentially be above-ground caves made of Martian rock, posing potential health risks to human inhabitants. Additionally, the lack of knowledge about Martian soil composition complicates the construction process. This is where inflatable habitats come into play. The beauty of inflatable habitats lies in their simplicity and efficiency. Ready-made inflatables can be packed onto a rocket and transported to Mars. Upon arrival, these inflatables self-inflate, deploying solar panels to power themselves. They await the arrival of human crews, making them a straightforward solution for establishing the first human settlement on a planet located 291 million kilometers away. The simplicity of this approach becomes evident when considering the challenges posed by launching payloads into space. The aerodynamic load on any vehicle passing through an atmosphere increases with the square of its diameter, necessitating smaller launch vehicle diameters. In contrast, inflatables allow for more substantial living spaces with a given mass. Moreover, some inflatable designs offer advantages in terms of space debris protection and radiation shielding. For instance, the B330 inflatable habitat outperforms typical aluminum shell designs in ballistic protection. In addition, the B330 provides radiation shielding comparable to or even greater than that of the International Space Station, while significantly reducing the harmful effects of secondary radiation. With these benefits in mind, inflatable habitats stand as a compelling option for human spaceflight. Are the conditions on Mars conducive to human habitation? This question remains at the forefront of Mars colonization discussions. While organizations have proposed plans for human expeditions to Mars, no one has yet set foot on the planet, and return missions remain uncharted territory. Landers and rovers have indeed provided valuable data about Martian terrain, but these robots alone cannot provide the comprehensive information required for human habitation. The challenges and perils of Mars colonization are substantial. They include exposure to radiation during travel to and on the Martian surface, the presence of potentially toxic soil, gravitational disparities, the psychological toll on Mars isolation from Earth, limited access to water, and frigid temperatures. The vacuum of space itself presents a significant hurdle, as humans require a life-sustaining atmosphere. In this context, inflatable habitats emerge as an optimal choice for human spaceflight, offering reduced weight and compact packing size, essential elements for successful launches. Now let's take a closer look at the progress made in the field of inflatable habitats. Bigelow Aerospace and NASA have been at the forefront of inflatable habitat research. NASA, in particular, has been actively exploring inflatable lunar bases in collaboration with the Planetary Surface Habitat and Airlock Unit. Although still in the early prototype phase, NASA's efforts offer conceptual insights into the use of expandable technology in space exploration missions. After Bigelow Aerospace was dissolved, Sierra took up the mantle, partnering with the Blue Origin to develop the future orbiting Reef Space Station. This interconnected, flexible living habitat draws inspiration from the TransHab concept, featuring a fully inflated structure measuring 3 floors in height and 27 feet in diameter. Once launched into orbit, the structure self-inflates and navigates to its designated location using its own thruster system. Its soft outer shell conceals layers of a highly resistant material called Vectran, a liquid crystal polymer-derived fiber. Sierra anticipates a lifespan approximately 60 years for these inflatable habitats, with the ability to repair punctures as they occur, assuaging concerns about catastrophic failures. One key advantage of inflatable habitats is their efficient radiation shielding. These soft shells can incorporate polyethylene, a hydrogen-rich polymer, into their structure to serve as an effective radiation shield. This innovative approach ensures the safety of inhabitants by minimizing radiation exposure. Additionally, inflatable habitats are designed around a solid core that houses essential facilities such as communication systems, life support equipment, power sources, research instruments, medical supplies, and exercise equipment. These core components are pre-positioned before launch, and astronauts transport them to the inflatable sections upon arrival. Inflatable habitats represent a promising avenue for space exploration. They offer a unique means of transporting volume into space, overcoming the challenge of carrying mass into orbit. While the 16-meter sphere design we've explored may not serve as a permanent home, it holds potential for food production and recycling systems, particularly in the initial stages of Mars colonization. Longer missions will demand greater interior volume. Ultimately, the allure of exploring an uncharted planet beckons, and the adoption of innovative technologies, such as inflatable habitats, brings humanity one step closer to making this dream a reality. As we conclude our exploration of inflatable habitats, one cannot help but ponder the mysteries and opportunities that lie ahead in the realm of space exploration. The allure of Mars, with its untamed landscapes and the promise of scientific discovery, has captured the imaginations of many. It is a testament to human curiosity, ingenuity, and the relentless pursuit of the unknown. So are you ready to embark on this interplanetary journey? Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode.